G'day guys, it's Alex here, Victor Kilo 2 Papa Radio Charlie here in Australia. For those of you who have seen my video that I put up on my YouTube channel recently, I've made myself a backpack portable station, and with my backpack station I talk to other backpack stations around the world. Including Dave G4AKC in the UK. You'll probably also recall from looking at the video that I actually spoke to him 59 on low power, and low power on my Clansman radio is in fact about 2.5 watts. Pretty remarkable, even I was pleased with that. Since I put the video up on YouTube, guys, I've been inundated with questions, technical questions on how to build a backpack radio just like mine. So what I've done, I've put together a pretty comprehensive video here on how to make the backpack radio, how to duplicate it just like mine, how to make all the individual components, how to put them together, how to tune it, and how to operate it on the beach as well. So sit back guys, it's a pretty comprehensive video. We're going to head into the classroom, we're going to do the theory first, then we're going to look at the individual parts of the radio, and then we're going to head down to the beach and tune it up and get it on the air. So follow me guys, we're heading to the classroom. I think the best way to understand how my station works is to get into a little bit of theory and talk about each individual part of the installation and how it all fits together and makes my ground tuning unit backpack radio operate so well. First of all, I just want to talk about the concept of a ground tuning backpack or ground tuning station in general. The whole idea is to set up a capacitively coupled ground tuning current that goes into ground. It's not a set of radials that are tuned to length. It's actually a capacitively coupled system that radiates RF energy into the ground. And the better the ground conductivity, the better the ground tuning unit operates, and of course the station operates more efficiently as well. This is why going down next to the ocean and standing or setting up your station just above beautifully conducting salt water or beautifully conducting salt ground provides an excellent capacitive couple to ground. And this is the secret behind the ground tuning unit, and in my case, my ground tuning backpack radio. Okay, let's identify the parts and see how they all fit together and what they do. First of all, I'd like to talk about the radio and the backpack frame. The radio, in my case, is a Clansman 320 used by the British Army, perfect for portable operation, battery operated, etc. Or this could be any HF transceiver that you want to use. There we then have a backpack frame, and look, the Clansman offer a beautiful frame at very, very economical price second hand. It consists of two halves that bolt together that unfortunately aren't electrically connected together because they've got paint on them. So when they clamp together, they don't provide an electrical circuit between the two. So you need to put a jumper lead between the two halves of the backpack frame to make sure that they in fact contact. And between the radio and the backpack frame, we've got a piece of insulation. Of course, the radio has to be insulated from the backpack frame. In my case, I've used just a piece of nylon cutting board. Very easy, very economical, buy it down the street. You could use any insulation you want, including timber. Okay, next I want to talk about the feed point. The feed point can be any feed point or any antenna you want to use. You can use one of these MFJ 1979 telescopic stainless steel whips if you want, or you can use a fiberglass pole with a piece of wire taped to it. Whatever you use is your choice, and it needs to be a 1/4 wavelength resonant for the 20 meter band, or if you want to make it for another band, it just needs to be a 1/4 wave resonant antenna for that band. Okay, the feed point is such that you've got the element connected to the center coax core of your feed line, and this particular feed point has to be insulated from the frame. So you might mount it on another piece of nylon board, or you might come up with some ingenious way to insulate this particular feed point from the backpack frame where it clamps on or mounts. Simple as that. Next, I want to talk about the ground tuning unit. This is a capacitor and inductor in series inside of a box. We're going to talk about this in detail next. The ground tuning unit connects via the screen on the coax cable. So we're looking at the grounding side of the transmission line. Comes into the ground tuning unit, out of the ground tuning unit, back up to the backpack frame. And the backpack frame is actually going to be used as the radiating element that radiates, capacitively couples the station to ground. Okay, now depending on what sort of a backpack frame you use and depending on how far that backpack frame is above the ground, will sort of work out how much metal you need to radiate the ground current into ground to give you a perfect tune at your feed point. So as the backpack frame moves above the ground, you need more metal, okay? And in some cases, you need to add a piece of wire onto your backpack frame to give you an additional radiating element into ground, okay? Now remember, this is not a counterpoise. This is just a piece of wire. Could easily be a piece of metal. You could even have an alligator clip going onto your frame, going onto a piece of aluminium foil above the ground. But we need, in many cases, to add a little bit of extra metal to ground. In my case, I just use a piece of coax. Now, this confuses a lot of people, thinking that the coax is used as some sort of a feed line, but it's not. I'm just using a BNC connector, in fact, at that point on my ground tuning unit, and I've just got a piece of coax connected onto the BNC connector, and I'm only using the screen on the coax. So yeah, what I do is I make up a number of different length short pieces of scrap coax that I have around the place, and I think one's 2 feet, one's 3 feet, and one's 4 feet long, and I just put those on, clip them onto the BNC connector because it's an easy connector to clip onto. I could simply, instead of having that BNC connector there, I could even have it on the frame if I wanted to. And all I do is, depending on how far above the ground I'm over, or what sort of ground I'm over, depends on the length of my little additional piece of coax wire that's helping me capacitively couple to ground. Okay, so I'd like to say at this point as well that the ground tuning unit, the original concept of the ground tuning unit was come up with by Dave. I'll just write his name here, Dave. Everybody knows Dave over in the UK. Dave is the big station out of Blackpool, and Dave's call sign is G4AKC, and Dave is the original inventor, let's say, of the ground tuning unit, this fantastic unit that enables us to set up stations on the side of the ocean and talk to the world on low power, just as you've seen in my video. Let's look at the ground tuning unit in detail. I'd like to point out again that the original conception of this ground tuning unit was come up with by Dave, G4AKC, over there in Blackpool. Dave's got his own website. You can look him up, just Google him, Dave, G4AKC. Lots and lots of great videos on there, and lots of explanation videos on how to build different concepts that he's come up with. But anyway, putting that aside, let's have a bit of a look at the ground tuning unit in detail. Now, this particular drawing that I've got up here is the original conception for Dave's ground tuning unit. So let's have a look at the parts that live inside that little box. Okay, so in the original concept, there was a variable inductor, a variable capacitor, both in series, with a current monitoring circuitry built in. And the whole idea was that you tuned your variable inductor and your variable capacitor to give you maximum ground current through the ground tuning unit. And how you would know that you had maximum ground current was through this current monitoring circuitry that was originally in the original concept. Simply a toroid with a couple of turns on the primary, about 20 turns on the secondary, a diode to rectify to DC, a capacitor to pump up, and a resistor here to give you the right amount of reading on a meter. And I want to stress here that the reading on the meter really meant nothing number-wise. The whole idea was we used this particular meter to monitor the current so that when we had these set in the correct position, we would know we had maximum current. And having maximum current would be the correct tuning for the resonant antenna that was connected to the grounding system. Pretty easy, and was easy to build. And I remember building my first one of these many years ago when I also had a trolley radio, just like Dave's original concept. Worked extremely well, had lots and lots of DX copies around the world, but hey presto, we've come up with the 2021 version, both Dave and myself, of the Backpack Portable. So let's have a bit of a look at how this circuitry has sort of changed for our Backpack version. In the Backpack version, Dave and myself both separately come up with the same idea of doing away with this current monitoring section of the ground tuning unit for simplicity. So instead of using a bit of circuitry to monitor the maximum ground current, what we've actually done, we've looked at other means to determine the perfect match for our antenna. And look, one simple way is in your initial setup of your, or construction of your ground tuning station, just use an antenna analyzer, and the antenna analyzer will show you that your feed point is in fact getting very close to 1-to-1. And when it's very close to 1-to-1, you will assume that your ground current through your GTU is going to be pretty well at maximum anyway. Okay, so we don't want to be carrying an antenna analyzer out with us every time we get on the air. So take away the antenna analyzer and introduce a field strength meter. Okay, so we initially set up our station, initially when we first built it, using an antenna analyzer, and we might have a signal strength meter sitting next to us as well. So after we set up the station to give us the right feed point match, we might connect the radio up and vary the capacitor and find out that in fact lo and behold, our field strength meter is giving us the maximum reading at resonance anyway. Okay, so we can take away this current monitoring part of the circuit and just simply introduce a field strength meter. So yeah, tune your ground tuning unit up to give you maximum field strength. So initially, when I set my radio up on the side of the ocean, I'll set it up and I'll put it into low power CW, or in the Clansman case, we've got an antenna tuning which produces about 2 watts. It's very similar to CW, and I simply press the button and I look at the signal strength meter that's sitting on the rock next to me or on the ground next to me, and I simply tune up my ground tuning unit to give me the maximum field strength. And I know straight away that I've got maximum current to ground. One thing I'd like to point out on the Clansman 320 radio that I use, it also has a thing called a reflector meter, and that's an antenna match meter. So not only can I look at the field strength meter to illustrate my maximum or best match at my feed point and my maximum efficiency into my antenna, but my reflector meter also reflects that same result. So the reflector meter is hard over in the 3 o'clock position, which gives me perfect match. So we don't need this complicated little part of the GTU circuitry. Looking at these other 2 items in the GTU, here we've got an inductor, and look, these inductors aren't that important, to tell you the honest truth. You can make a simple air inductor if you want to, or you can make one on a toroid. Look, I've made them on T150/2, the burgundy coloured toroids, with about 6 turns. 1 turn between each contact on the switch. Buy yourself a rotary switch, wind a simple toroid with about 1mm wire on it, solder on some little tails onto the toroid, bring it down to a switch, and rotate the switch to give you your different positions on your inductor. Okay. And secondly, in series here, we've got an air capacitor, and these air capacitors you can buy on eBay. They are a bit expensive lately, but you can get them. Something around 20 picofarads up to 350 is common, but if you're lucky enough to get a 20 to 500 picofarad, it's even better. Okay, so air variable capacitor used for tuning the capacitive side of things. I'd like to add an observation of mine. This is purely my own observation and needs to be proved by yourself on your installation. But the last couple of ground tuning unit installations that I've made, I found that when I've tuned them up to resonance, getting maximum ground current and getting a nice one-to-one match on my feed point, in fact, my variable inductor has in fact been in the shorted out position, so it's not even in circuit. Okay. And that's led me to believe that, is it really necessary in these types of installations when I only been varying my capacitance to get the match to match perfectly? So I would suggest that if you're going to try this, I know this sounds extremely simplified, but if I was going to make a ground tuning unit and trial it on a similar station than what I've got to show you here in this video, I just simply use a capacitor. So I do away with that and do away with that. So into the box, through the capacitor, and out of the box. Almost too good to be true, isn't it? But there you have it. That's just purely my observation, because believe it or not, I've checked and checked again. Every time I tune this up perfectly, I look physically at the inductor in the box, and lo and behold, there it is in the shorted out position. Definitely worth a look, that one. Okay, you may have noticed I forgot that wire on my diagram, so I've just added it in case we've got any super sleuths out there that are saying he's forgotten a wire on his variable inductor. So there it is. I'd now like to talk about the feed point impedance of our portable station here. Very, very important to get a good match. We all know that. So let's just go over a little bit of theory about how it works and why it's so important. First of all, I'd like to talk about maximum power transfer. Maximum power transfer occurs when the output impedance of the radio equals the input impedance of the feed point. If we can get those the same, we can transfer all of our energy into our antenna system. If they're not quite the same, we get some reflected power. So we don't really want reflected power. We want all of our power to go up the antenna. So let's just have a bit of a look at what we're facing here. Okay. So if we really look at our antenna on our Backpack Portable, it's a little bit like a dipole set in a vertical fashion, where we've got a quarter wave vertical antenna and the other quarter waves taken up with our earthing currents that are going to capacitively couple to ground. And if that's the case, and it resembles a dipole in that way, we would expect a feed point to be around about 75 ohms. That's not unreasonable. It mightn't be 75, but it'll be around about that. Okay, so let's just have a look at what would happen if it was 50. If in fact the feed point was 50, we'd have 50 ohm output, 50 ohm feed point. 50 divided by 50 equals 1. We'd have an SWR of 1. Perfect. But in this particular installation that we've got here, it's in fact 75, or close to it. Okay, so that will give us 75 divided by 50 equals 1.5. Not real good. Look, it's not bad. We could live with it, but it's not that good. We can improve it. So let's just work on making our station just that little bit better. So we can match the 75 ohm feed point using a method called the 12th wavelength method. Okay, it's a little bit of complicated mathematics in there, but here's the short version summary. Okay, so the short version summary is we've got a radio with 50 ohm output, got a feed point of 75, and we want to match it using two short lengths of coax. In fact, they're going to be 12th wavelength lengths. The first one here that coming out of the 50 ohm socket will in fact be a little piece of 75 ohm coax, and that'll directly join on to a 50 ohm section and then off to the feed point. So how long should we make these lengths to match it perfectly? There is a formula, and let's have a look at that formula. So the formula is this magic number here, which is a constant, 0.0814 times the wavelength in meters, and for 14.2 megahertz, around about the middle of the band, it's 21.112 meters times the velocity factor of the coax. And in this case, RG59 coax is 0.66, and in fact I've looked it up, and RG58 A/U is also 0.66. So if we work these numbers out on the calculator, in fact they come out to be 1.134 meters in length. So in other words, both of our sections here are the same length, and that length is 1.134 meters long. 75 ohm onto the radio, 50 ohm onto the feed point. Connector on there to the radio, whatever connector you use onto your feed point. You can either put connectors on these ends and just join them through a union connector, or in fact there are some smart little techniques to solder the center conductor and then solder the screen as well. But in my case, I just put a connector, and I used a barrel connector in the center to join them together. Hey presto, 50 matches 75, maximum power transfer, and yeah, no lost power, all good. Okay, now that we've got all the theory out of the way, let's have a look at the actual station and recognise the parts. You see here we've got my antenna section. This one here is my fiberglass telescopic antenna that I simply tape my antenna element onto after it's extended. I've put a banana plug on it, and then there's the feed point. I've used one of these feed point connectors. You can either buy these online, but I managed to buy that one down at my local shops. This wire here goes off to the ground tuning unit, and of course that's the antenna connection. Okay, simple as that. By the way, if you chose not to use a fiberglass antenna like I've done, there are other options out there. Notice that I've put another piece of plastic tube, and I've just connected the plastic tube onto the frame. In fact, I've just used cable ties to put it onto the frame. I've put in a rubber stopper at the bottom and some cable ties to hold it onto the frame here. It's quite solid, to tell you the truth. I'm really quite happy with it. But I'm a sort of an old-fashioned guy. I like my fiberglass telescopic pole, and here I've just put a rubber O-ring on to stop it falling all the way down. I can set that at any height that I want with the rubber O-ring. Pretty good, eh? There you go. Okay, so that's basically how it works. Now look, if you're not a big fan of the fiberglass pole and taping on the cables, there are other options, and I've got another option here. You can use the standard antenna base and grab yourself a telescopic stainless steel whip. This one's a Chinese copy, but basically they're the same as the MFJ 1979 5 meter or 5 and a little bit meter telescopic antenna. Simple. Okay, and by the way, just to mention, on the base here, remember what I said, the base has to be insulated from the frame of the carry frame. I introduced an additional nylon washer there that actually insulates the feed point from the bracket. Okay, if you didn't have that, then you'd have to insulate the clamp from the frame. So this the feed point coax has got to be insulated from the frame. So if I was going to use this one here, I would simply probably bolt it on to somewhere there on the frame, and that would give me my feed point, etc., etc. Pretty neat. Yep. I don't know, maybe one day I might convert my station and use that antenna. But anyway, that's the option for antennas. My Clansman radio is not equipped with an audio amplifier, so I listen to the radio by a set of headphones or a handset. In the case of operating near the ocean, it's quite noisy there, so a headset is the preferred listening. But just to make things a little bit more convenient, these Clansman radios actually have two output audio sockets, and one I've got connected permanently to a nice, very, very small little speaker, okay? And that little speaker, not that loud, but loud enough to make recordings and loud enough to stand next to the radio and listen as well. And you'd be surprised the amount of spectators you get when you operate your radio next to the beach. They all want to say, what are you doing and what's going on? And for them to stand there and listen in to perhaps a station on the other side of the world is impressive for the crowd. Moving down from the feed point, I've got my transmission line. And remember here we talked about the 1/12 wavelength match. Well, here you'll see I've taken up the slack in the coax by winding it around and around and around my mounting pipe. And it goes down, comes out here, and you see taped in the red there, that's the connector between the two 1/12 sections of coax. Then we go down the bottom, and I've wound some more slack down there for the other section of the 1/12 section, and then back up and into the TR socket on my Clansman 320 radio, which is in fact the 50 ohm output from the radio. So out from the radio, through the two matching sections of coax and into the feed point. Pretty simple. Here I've got my ground tuning unit. I've got my inductor. Remember the one that I said that possibly not in use, but anyway, it's there anyway, but it just happens to be in the shorted out position. And here I've got my variable capacitor. Now this is the bit that I get asked so much about. Why have you got this piece of coax on here? Why have you got hanging down on the ground? Okay, and as I pointed out before, it's not really anything to do with coax. This could be just a simple terminal, and it could be just a piece of wire, and it doesn't really have to be connected onto the ground tuning unit. This could be connected straight onto the frame as well at any point, because this wire here actually joins onto there, but it also joins directly onto the frame. So whether it's connected on the frame or it's connected there, it's the same point. And I just happen to use the BNC and a piece of coax for the convenience of just using a piece of wire. So it's just simply a piece of wire. Okay, now I've mounted it here with cable ties again. There's some ingenious little cable tying around here and whatnot, and it actually sits on there quite strong, quite strong. The box is a good seal, operating near salt water, etc. It's got a nice little seal on it, so it keeps the air out of the salt air out of my capacitor and inductor. And the really good thing is when I'm wearing the backpack, I can put a signal strength meter on a rock somewhere, and I can just reach my hand round and turn the variable capacitor and tune up my ground tuning unit for my maximum power when I'm wearing the backpack, because when I'm wearing the backpack, I can't see my reflector meter on the radio that also tells me the same thing. So it gives me the opportunity to use that field strength meter to tune up my ground tuning unit. Next, I'd like to talk about the insulation. And remember I said that the radio had to be insulated from the frame. And here I've used two rectangular pieces of cutting board, nylon cutting board. It's 6mm thick. And normally the Clansman radio would bolt through that bar there, straight onto the radio with that screw. And what I've done, I've just raised the radio up by, well, probably about 2 inches, and screwed the screw into the radio via the insulation piece, and introduced another nut and bolt here. And I've done exactly the same down the bottom, on the bottom section as well. Pretty simple, a couple of rectangular pieces of nylon, drill a few holes, and you've got your Clansman radio bolted onto your back frame. And of course, if you weren't using a Clansman radio, you were just using a commercial radio, you would simply bolt a section or a big rectangle of some sort of insulating material between the backpack and the radio. Simple as that. So this is the plate adapter carrier. This is the part that screws onto the radio, and then the other part is the frame itself. And notice that just clips on. It's got a clip on there that clips on, and there's these wind-up clamps just here that clamp the two halves together. Remember what I was saying, that you need to separately connect the two halves? You see there's two wires connected onto there, and those two wires that are connected onto there, you can see they bridge from the ground tuning unit to there, and then from there around, and I think I've got it, yeah, there it is there. I've got it connected to that part there. So these two parts of the carry frame are in fact electrically connected together. And of course it's got the extremely good strapping arrangements that are adjustable. These things are just made for a backpack radio, aren't they? British Army used them for about 30 years and they're very, very successful. They're actually quite comfortable. The whole thing probably weighs about 12 kilos. So yeah, even though I've got a bit of a crook back, I can carry it around quite easily for a while. And of course, when I get sick of carrying it, I can sit it on a rock and sit beside it and operate it just the same. And just for those who are not familiar with the Clansman 320 British Army Manpack radio, this is what I use. It's a very, very robust, funny looking thing, completely waterproof, so if I get rained on, it doesn't really matter. The band selection switch, the frequency selection, I've got a gain control, a bit of a sideband CW switch, and an antenna tuning section, low power and high power switch at the bottom. It's a very, very simple rig. It puts out about 30 watts on high power and about 2.5 watts on low power. And normally a battery clips on, there's the battery clip there. And normally a battery clips on the bottom. I just happen to have my battery on charge right now. So, yep, basically that's what the radio looks like. But as I said before, it's not necessary to use a Clansman radio. You can use any commercial rig you choose. I thought I'd mention there is an option in backpacks. Backpack frames. Clansman also makes a lightweight backpack frame. It's virtually just the radio adapter fashioned directly into a backpack, padded backpack. So there's no real frame as such. It's a sort of a mini backpack. Some people call it the paratrooper or the patrol, or even that wonderful word SAS backpack. But that is an option. And if you're going to make a station and completely wear it on your back only, then that particular frame might be a good option, being a little bit lighter, smaller, and especially if you had a smaller radio, that would be a really good option. But when it comes to asking the frame to stand up on the beach and operate next to it by sitting down on a rock, you might find that the slightest puff of wind will just blow this thing over, because it's got very poor balance when it comes to standing up by itself. It's really made to be worn at all times. So this is the reason that I haven't used the lightweight paratrooper type patrol backpack. Lastly, I just want to revisit the feed point. You'll notice on this radio the positioning of the feed point, it's quite high compared to the radio. And I find that it's very close to 75, 73 ohms impedance. I've been told by Dave, G4AKC, who uses this type of antenna, and he mounts it in a more centralized position there. So it's a lot lower than my feed point. He tells me by lowering the feed point on the backpack, it actually has the result of lowering the feed point impedance as well, closer towards the magic 50. I can't say this is true or not. Dave says it is, so I've got to accept that as being fact. But I would suggest look very closely at that when it comes to feed point impedance.
G'day guys, it's Alex here. I've just come back down here to the south coast of New South Wales to a place called Sandon Point to demonstrate how to set the radio up and how to tune the ground tuning unit. So we'll just go through that step by step. Before I start this test, I've got on the air and I've cleared the frequency and I've declared that I'm going to do a test. So everything's right to go ahead now and demonstrate how we tune this ground tuning unit to get the maximum power output of the radio. So let's do that. Okay, I'm set up here with my radio station, my usual spot, my favourite rock. And what I'm going to do is demonstrate on how to tune it. Now remember, the ground tuning unit tunes the ground current to the ground, and at the moment we're sitting on top of a rock here, which is quite a considerable distance above the wet ground. So I'm probably going to anticipate that the frame is not enough cable or metal to tune this thing properly. I've got my field strength meter set up there so we can have a bit of a look at what we're doing. I haven't got any additional cable connected here, so I'll push the button and twiddle my little capacitor here with my finger, and we'll have a look at what we got. Okay, so there we go. Looking at the field strength meter there, it's just above the 10 there, and looking at my reflector meter here, which indicates my match, I'm going right through the capacitance here, and I'm not getting any movement on the meter at all. So that's telling me that it's not the best match. So what I'm going to do now is put some lengths of cable on and try it again. Right, so I've put an additional piece of cable on. This is probably about 3 feet long, this one. It's dangling down there. It's not touching the ground, but it's just above the ground. I'm going to expect an improvement here, so let's have a bit of a look at what we've got. So again, hitting the tune, looking at the meter, adjusting for the best field strength. Okay, now it's up around the 20. It was up on 10 before, now it's up to 20. Looking at the reflector meter, I'll twiddle it again through the capacitance. Well, we've got a bit of a movement on the reflector meter. Okay, so what we'll do now is we'll take that piece of cable off and put a longer one on. Try again. Okay, so I've put a longer piece of cable on. Now remember, this is increasing the amount of metal. And this particular one goes down there. It's about 6 feet long, about 3 meters. And notice I've got it curled up there just above some wet sand. Now I'm expecting now to have a much better coupling to ground, much better power output, much better everything. So let's just see how we go, and we'll do it now. Okay, pushing the button, having a look at the meter. Whoa, much better. Look at that, heading towards about 60, maybe 70 on the meter. Looking at the reflector meter up here. Whoa, that's a very good match. Okay, that's about as good as this radio will get. That's about a perfect match there. Okay, so it just goes to show what you do to get your ground tuning unit adjusted. And remember, the frame is part of the grounding electrode, and the ground tuning unit is the fine tuner, but the coarse tuner is the amount of extra metal that you've added to the ground tuning electrode. Now look, if I would have been sitting down there on a rock just above the wet sand with the radio 6 inches above the damp soil down there, or the damp sand, I would have expected to get a really good match, probably with just the backpack alone, or at the very least with a very short piece of cable on here, maybe only 1 or 2 feet long, and that would have been adequate for that particular match. Okay, so I hope that's all helped. So what I'm going to do now is get on the air and start looking that way to try and get some contacts into Europe. So we'll put all of our theory into practice and get it happening. CQ. This is Victor Kilo 2, Papa Radio Charlie, pedestrian port, calling CQ, over.
Temperature just above 0 degrees, but it's clear sky, a clear sky, and I guess the moon is in the sky here at the moment. So back to you, Victor Kilo 2, Papa, Radio Charlie, G4AKC, bicycle mobile,
Yeah, G4AKC bicycle mobile. Great to hear you, Dave. Down on the beach here with the backpack again, mate. And yeah, making a few contacts, but not a lot of Europeans coming in at the moment. A lot of Japanese, but look, your signal's coming up all the time, Dave. The weather here is pretty cool this afternoon and quite breezy as well, over.
Roger, roger. Well, you think you got a lot of breeze, huh? And I tell you, we had a meeting in the local club. We had a meeting in the local club yesterday, and I showed the guys the film that you sent me, and they were quite impressed, Alex. What'd you say, over?
Yeah, SM1 Alpha Lima Hotel. Great speaking with you again, Eric. I'm a movie star, mate. I'm a movie star at your local club, over.
Yeah, that's right, Alex. So, where are you today? Are you at the same QTH or any changes, over?
I'm at the exact same QTH today, back on the edge of the ocean. In fact, I'm making a nice video here right now for you, Eric, and I'm going to send it to you on QRZ, mate, when I've finished this conversation, over.
Appreciate it. It's always interesting to see and hear what it looks like from the other end.
Eric, can I reduce my power? Can I drop down to 2 watts, please?
Yeah, give it a try.
Okay, this is a Victor Kilo 2, Papa Radio Charlie, calling Eric, SM1 Alpha Lima Hotel on Gotland Island on 2 watts on my Clansman 320, over.
VK2PRC portable. Pedestrian mobile, SM1 ALH. You're still audible. You're 5 and 2. 52 on a very clear frequency, Alex, over.
I just changed back up to high power, Eric. High power at 30 watts, mate. Fantastic. That's pretty well spanning the whole world on 2 watts. Just goes to show you what an afternoon at the beach can do, mate, over.
Yeah, right. Yeah, you were solid Q5. Solid Q5 even with a 2 watts, Alex. So thanks for calling in. And hope that you will make some more QSOs, Alex, and that you have good weather on the beach.